I know.
Got a cat.
That looks like a cat. We used to have a cat kind of similar to that. Hold him up a little bit higher so I can see his face. Yeah, similar. That one, he's a little bit bushier. He almost looks like he's got Maine Coon in him. He's a big
Yeah,
one.
Zoe. Zoe is a Maine Coon.
Does he?
Yeah.
Uh,
Yep.
I'm testing my headphones.
uh-huh.
Is it okay? So I can hear you now.
Okay. We'll start in about 5 or 6 minutes. So if you want to go to the restroom, get a drink, or get something to eat, that's fine.
Okay.
Brenna, can you hear me?
Yes.
Okay.
Mr. Manifesty, it says you're muted.
Yeah, I muted it in the
Okay.
background. Yeah.
I think my sister is reading the Wednesday Wars.
I've never heard of that. What's it about?
It's it's like this kid is like he's in the 7th grade class, and one of his teachers is like he thinks one of his teachers is out to get him,
Ah,
and
huh.
it's like, and then there's also it's like a historical fiction kind of thing.
Oh.
It's because the Vietnam War is going on at the same time too. Yeah, it's a pretty good book. Near the end, there's like a betrayal or something.
Hey, David, can you hear me? David, can you hear me? I'm not sure David can hear.
David.
I can hear you.
Oh, you can. Okay.
I had the mic muted. I don't know how to change my name. This is my brother's name. How do I do it?
We'll get started here in about a minute. All right, I think we're going to go ahead and get started then. Let me share my screen with you all. All right. So let me open up the agenda here. So today is Wednesday. So what we're doing today is we're just simply going to be using that model we found for the last lab that we whiteboarded. By the way, probably should talk about that a little bit. If you haven't already, you need to turn in your, oops, yeah, you have to turn in your Fantastic Lab. So I have that, I think, from everybody here. I'm not sure. Let me check here real quick. Oops, wait a second. Did I miss something? All right, looks like I messed something up. But I think I have labs from all of you, I think. I don't know what I did with it though. So I think you guys are all good, but I think there's some people haven't done the lab yet. So just make sure I get that from you. It looks like Jasmine just turned hers in to me. So anyway, make sure I get that from you. And the next thing we're going to be doing is we're going to be whiteboarding the worksheet 3. And so what you're going to do is you're going to click on this link here in a second. It says, here's where the whiteboards are. So you'll click on this. And when you do that, it'll take you to a folder. It says period 1, period 6. You guys will click on period 1. And it has all your names here. So what these are the whiteboards for worksheet 3. You can I think you guys, can you see each other? I think you can, right? So if you wanted to pair up with a partner and just use theirs, let's say, I don't know, let's say Kylie's just coming in. So it's Jacob and Kylie. Let's say they wanted to, just work on Jacob's, they can. So I'm just going to go on Jacob's here. And everybody's going to be whiteboarding worksheet problem number 1. So it kind of looks like this, for instance. And so what you're going to do is you're going to sketch a picture. You're going to read the problem and decide if the system is balanced or not. Notice it says it is accelerating. You're going to draw a force diagram. So right there on your picture, you're going to draw a force diagram, stuff we've done before already. Okay. If you're like, I don't know how to draw a force diagram, what you could do is you come up here and you can just select the arrow and you could draw the forces in and that kind of stuff. And then you're going to solve it as best you can. Okay. So why don't I go ahead and give you a little bit of time to do that. And so if you're like, I don't remember where that was, if you go to the Canvas calendar, you go to Wednesday and you click on here, it'll take you to that folder. And then you just open up period 1 and find your name and start whiteboarding number 1. Okay. So I'm going to give you about 5 minutes or so to start working on that. All right. Okay. So go ahead and start working on that.
I went to my own file thing. It said,
Yeah.
oh, it just showed up.
Okay. So everybody is now going to their own folder, or if you want to work with a partner, you can work with them, and you're only doing problem number 1. Okay, and we're only going to give you about 5 minutes, and just do the best you can. And then I'm going to kind of do mine as well, so you can kind of see what it should look like. So what's nice about this is at the very end, you should hopefully have some notes just by you drawing the whiteboard and stuff. Okay. So I'll give you about 5 minutes.
What one is it? I'm sorry.
So for people that came a little late, I think I'm going to go through again while other people are still working. What you're going to do is you'll go to the Canvas calendar. We also talked about that, hey, you need to turn in the Fantastic Lab if you haven't done that from Monday. Most people I think have done that already. But then what we're doing is we're starting a whiteboard worksheet 3. So you're going to click on this link. And you'll see when you click on the link, period 1, period 6, you'll click on period 1. And you will find your name. So let's say Imani here. And we're starting to whiteboard number 1 here. So you'll just click on number 1 and you'll kind of do what it says. You're going to sketch a picture of what you read here, sketch a picture, read the problem, figure out if it's balanced. Notice it says it's accelerating. And then you're going to draw a force diagram for it. So I'm kind of hoping you remember how to do that. And then finally, you just see if you can solve it. Okay, and notice I give you the 2 equations that we know now. F net equals MA and FG equals M times 10. So see if that kind of helps you, right? Okay, so I'm going to stop sharing again. And give you guys another about 4 minutes. And then I'm going to go ahead and show you my answer then, okay? Give you about, let's see, give you another minute or so. If you're not done, that's fine. It's not a big deal. I just kind of want you to have some kind of notes. I want you to try it. All right, that should be enough. Now I'm going to go ahead and share my screen with you. If you're not done, it's not a big deal. I just want you to try it, okay? So let me share with you. All right, so this is the one I'm working on. So the first thing I did was kind of sketch a picture. By the way, can you guys all see this? Yeah? Can you see it? Yeah, okay. So it says this cart, I didn't have time to put wheels on it, but this cart's being pulled on this frictionless track. And so here's my cart, and I'm saying it's frictionless and it's being pulled. And so down below it, you'll see this force diagram. There is a normal force straight up. It balances out this weight force straight down, force of gravity. And then there's a pull force. Notice there's no other force. There's no friction or anything. That's it. So is this balanced or unbalanced? Let's see if I can get somebody to talk. Balanced or unbalanced? You have to unmute.
Unbalanced.
Yeah, this is unbalanced, right? Yeah. So if it's unbalanced, it's going to start accelerating, which it tells you it does. Okay. We know what this force is here, this pull force. It tells us. So this pull force here is 3 newtons. We know what the mass is, so we can figure out what the force of gravity is, because the force of gravity is equal to m times 10. It says the mass is 2, so it's going to be 2 times 10, which is 20. Well, that's going to balance out the normal force, so the normal force must be 20 as well. And then finally, we're trying to figure out, let's see, what the acceleration is. Well, we got this new equation right up here. I'm going to go ahead and write it again. That new equation is F equals ma. F equals ma. It's really the net force, and I'm hoping you can see the normal cancels out the gravitational force. Those two cancel. And so the net force would be the pull. So for this one, the equation is going to be 3, that's the net force, is equal to the mass, which the mass is 2, times the acceleration. And so now we have to solve for the acceleration. So if you haven't done this already, can you get a calculator out and take 3 divided by 2 to figure out the acceleration? Can somebody shout out an answer? What'd you get?
1.5.
Perfect. 1.5. That's the answer. 1.5 meters per second per second. That's it. Or meters per second squared. You could say either way. Any questions on that one? Okay. So then the next one you guys are going to be doing is number 2. And in number 2, we have this car, or whether this SUV, and it's accelerating. It says there's this force that's resisting, like a friction or something. And then it wants to know how much force has to be applied to make it go forward, to make it accelerate. So the first thing is sketch a picture, read the problem, figure out if it's balanced or not. Notice it says accelerate. Draw a force diagram, and then solve it. So I'm going to give you about 5 minutes. So go ahead and start working on it. I'm going to stop sharing now. Okay, do the best you can. Number 2. Okay, I'm going to share my screen, but just kind of ignore me. For the people that just came a little bit late here, I'm going to share my screen so you know what you're doing. You're going to go to the Canvas calendar page. Look at Thursday. Please be aware, not Thursday, sorry. I wish it was Thursday. Make sure you turned in your fantastic lab to me. That's the one we whiteboarded on Monday. A lot of people have already, but not everybody. And then then we're whiteboarding worksheet 3. So click on this link here. We are period 1, so you'll click on that. And then you'll just find your name. So let's say you're Josh Brown. And what you're going to be doing is you're going to be whiteboarding. We're now working on problem number 2. So you click on this one, And you're just going to be whiteboarding that one and sketch a picture, read the problem, figure out if it's balanced or not, draw a force diagram, and then solve it. Do the best you can. In about 5 minutes, I'm going to show you how to solve it, okay? Okay, I think I'm gonna go ahead, and if you're not done, that's fine. So in a way, this is supposed to be notes for you. So I'm gonna go ahead and share my screen um, and solve the problem. I haven't even started it yet. I haven't had a chance. So let me share. Okay, so now we're gonna be looking at, hold on a second, sorry. Okay, now I want to look at problem number 2. So, okay, so I'm going to draw, I guess, kind of a car. We're going to say this is a car. SUV. Red, always like a red car. Okay, this is the ground, blacktop. Okay, so I don't know, it says there's resistant forces like from friction, or maybe there's air resistance or something like this. So I'm going to have the thing moving to the right, but there's, you know, air resistance or something. So the thing is moving this way. It's moving this way, but there's air resistance acting on it. Okay, so the first thing I'm going to do is draw a force diagram. So that dot there represents the car. And let's see, it would definitely have a normal force on it. It's going to be a weight force on it, and it would have a normal force on it. There's some kind of friction or air resistance or something on it. And it says it's accelerating, it's getting faster, so there has to be some kind of force that's to the right as well. All right, so let me name all these forces. So this one down here, this would be the force of gravity, force of gravity. This one up here would be the normal force, force normal. This one back here is the resistant force. I don't know what you want to call it. You can call it drag, you could call it friction, whatever. So I'll call it force of drag. And then this one here is like a traction force or something. So I'm just going to call it force though. Okay, so I'm going to go ahead and put in some numbers. I know what the mass of this truck or this SUV is, so I can figure out what the force of gravity is, because the force of gravity is just simply the mass times 10. It tells me what the mass is. It's 2,000. So it's going to be 2,000 times 10. And 2,000 times 10 on my calculator, I get that out, and I do that, I get 20,000. Well, that balances out the normal force. So the normal force must also be 20,000. The problem tells me how much friction or drag there is. It says it's 1,500. Okay, the question is, what is this force here that I'm trying to, I don't know what this force is. It's like a big mystery, but it says that the car accelerates. Let me see if I could circle that. The car accelerates at 3 meters per second squared. Well, we just found this new equation from the lab that you're turning in, that F equals ma. And so I could figure out, actually, I don't want you to think this is any F. This is actually the net force, like when you add all the forces together. So if I want to know the net force, that's just simply the mass, which in this case is 2,000, times the acceleration, and the acceleration is 3. That means the net force is 6,000. Now, that does not mean this force here is 6,000. That's not true, because this force has to be bigger than 6,000, because the gravity force cancels the normal. In other words, they're in opposite directions, so when you add those two together, you get 0. When you add the drag and this force F, you have to get 6,000. So that means that this force here has to be 6,000 plus 1,500. So then I have to get out my calculator, 6,000 plus 1,500, figure out what that is, and I get 7,500. Any questions? Everybody good? All good? Okay, so now we're going to do one more problem. Inside of your folder, there should be worksheet problem number 3. This one's actually a little bit easier than the last one, because now it says that it's going at a constant 18 meters per second. It's not accelerating. Will this be balanced or unbalanced? Balanced or unbalanced? Can somebody say something? Balanced or unbalanced? Can you guys hear me? Oh, okay. So is it balanced or unbalanced? You have to unmute yourself. I can't hear you.
It is balanced.
It's balanced, right? Okay. So could you, everybody go ahead and work
But
on.
I'm going to get it a lot faster, and I'm not going to look at it through the eyes of vectors, because the question, the only reason I'm sharing this with you is
So if you can go ahead and solve this one, and then I will share it with you in about 5 minutes. So go ahead and start working on it.
It's I'm raising my hand for a question.
Yes, yes. What's your question?
So you said this is our last problem we're doing together.
Yeah.
The rest is gonna be like homework and stuff.
No. We'll finish whiteboarding it. I really don't want this to go more than a half an hour. That way
Okay.
you guys got other stuff to do. And so no, you're not doing the rest of this. We're gonna do it together on Monday. We'll finish it up.
Okay.
But there's some of you, like, I'm not sure, I don't know, Devontae, I'm not sure if I have your lab or not. So some of you still have to turn in a lab to me.
Yeah. I'll make sure my lab is turned in. Don't worry.
Okay. Yeah, no, I can't remember, Noah. You might have given me your lab already. I'm not positive.
It's okay if I just turn it in again to be sure.
Okay, yeah. Yeah, you can all turn it in again if you're not sure. Okay, so let's go ahead, because I don't want this to be any longer than about half an hour. Even if you're not done with this problem, I'm going to go ahead and show you what I got, and that will be it. And then I'll just kind of review with you what you need to be doing. Okay, so let me share the screen with you. Okay, so now we're looking at number 3. I went ahead and was able to do it because it's similar to the last one. So all I had to do, sorry, I'm trying to move this out of my way. What I'm clicking on here. There we go. All right, so here's my SUV again, my truck. This time it says it's moving at a constant speed. Okay. I went ahead and drew a force diagram. This force diagram is balanced now. Hopefully it looks balanced. Oops. And so there's this gravity force down, there's a normal force up, there is this drag or friction force to the left, and then hopefully it looks about the same length, this force forward as the drag. Hopefully they look about the same length. That's the one I'm trying to figure out how big it is. It tells me the mass, so I can figure out what the gravitational force is, because it's simply going to be force of gravity is m times 10, and I can plug in 2,000 for the mass and figure out what the weight is. It's 20,000. That's the same as the normal force. If it's not accelerating, if it's going at constant speed, it's got to be balanced. So notice the gravity force balances out the normal. The drag force has to balance out this force forward. So can anybody tell me how much this force forward has to be then? How many newtons? And then we'll be done. You have to unmute yourself. Can't hear you.
2,500.
That's it. Yeah, 2,500. That's the answer. So, okay, so we just did 1 through 3, and we're going to be doing that on Monday. We'll do the other ones. If you're bored, sure, you can do it if you want, but it's not homework. Okay, so what is homework, I do want to talk about, is that some of you have not turned in your Google Drawing yet, or excuse me, your Google Drawing for your fantastic lab that we whiteboarded on Monday. So make sure I get that. All of you that are in this conference, and I have your names down already, you don't have to do this last thing I'm going to talk about, but I have to talk about it. Don't leave yet. So people have to take this attendance SWIC, which is really kind of over the problems we just whiteboarded. So let me click on it here. You're going to need a passcode to get to it, and here it is. Here's the code. So, so for the people who are not in this conference right now, you're going to have to do it. For the people who are in the conference, if you want to do it, you can. To see, it's not that hard. It's really based upon what we just did. But you are totally exempt from it. You don't have to worry about that. That's one of the things about getting up early. If you come and participate, then you don't have to worry about doing that. Does anybody have any questions? Okay, so make sure I get the lab from you. For the people who aren't here in this video conference with me right now, you have to also do this attendance SWIC, and here is the access code. Okay, so let me stop sharing and make sure I have everybody's name down. Yep. Okay, so I have Noah, David, Jacob, Kylie, Imani, Brenna, and Devontae. You guys don't have to worry about doing that attendance SWIC. You're good. You got all 100% points. You guys doing okay? Yeah, it was hard to get up this morning, wasn't it? Oh my gosh, I'm so tired.
I got up at 6 o'clock, watched some TV for like an hour and a half, and then
I'm tired.
I
Well,
know.
I'll see you guys then on Monday. We'll do another one of these conferences. So make sure you put it on your calendar, 7:45 Monday. That way you won't have to do attendance week if you come and join the conference. All right. All right. See ya. Bye. Later.